All right, we're live. Eran Haggiag, very excited to get to know you a little bit more. You are the CEO of ClearX. Let's start there. What is ClearX? What are you guys attempting to do in the world?
Okay, so first of all, thank you for having me tonight. I'm at ClearX. What we do in the last 4 years is developing blockchain-based settlement and contract automation systems. We do this to serve usually large enterprises and then trickle down to medium and smaller enterprises. Our biggest market that we operate in is the telecommunication market, where we are serving the biggest telecommunication companies in the world in different types of services, and we can talk about it more.
Yeah, I like this business a lot because it's behind the scenes. You've raised money from the telecom businesses themselves, which is a huge indicator. And pre-show, you were just telling me that you got back from a conference which your customers were selling other customers. How does enlighten me a little bit as to how the telecom industry works today, and particularly the payment aspect, which you guys seemingly are addressing?
Yeah. So I was quite amazed to see how manual things are in the telecom, especially in the wholesale business, but also serving enterprises and other customers. It's still a market where negotiations are being done in these conferences, like the one I've been into Dubai, sitting in conferences room or small tables, depending on the budget of the companies, and negotiated different contracts and deals between them. Orders are being done mostly by email with different order forms and stuff like that. It takes a long time to process them, to get the quotes, to get the orders. And then when invoices are being issued, there are discrepancies, disputes are arising, Excels are changing hands. Sometimes takes months or even years to resolve these discrepancies. So very, very manual thing for industry that does that runs the internet, right?
And so what would be an example of a customer of a teleco? So this is not a individual user. Like, it wouldn't be me disputing my Verizon cell phone bill. You're talking about something else.
No, it's when Verizon works with the Vodafone. Either, let's say, to take an example of the roaming business. So if you are a Verizon customer and you're going now to London or to Düsseldorf, and you roam and you get charged by Verizon for this, but actually you were using Vodafone network. So Verizon needs to pay Vodafone for this service, right? And they need to do it for all the roaming users that happens in the world. And each one of these have hundreds of connections to different operators in the world that needs to settle between them on very complicated agreements that can be based on different tiers, commitments that they do with each other, deals that are cross between them, like they're balancing the stuff. So there's many different models, and this is quite complicated, and this is being calculated in silos by each company, sometimes in Excel, sometimes in dedicated software. These things are not talking together, and then you got a lot of disputes between them. So it is for your individual activity, but you are not aware that all of that is happening behind the scenes.
Wow. Yeah, I was not aware. I figured it would be fairly automated, but I suppose it's not. What is the cause of the disputes? Why would it not be as simple as, hey, I'm in France and there's a French teleco server, and then Verizon just bills that server or pays that server? What are the disputes typically involving? The time or the actual data that somebody's using? And because I would imagine the inputs are fairly quantitative, right?
Yeah, you would imagine. So the first type of disputes would be around the data itself. So as one party is getting the data directly from their network, the other party is getting data sent back to their network. And as we're talking about, a lot of packets, a lot of data. I think every 10K that you're using on your phone is another record. So data starts to not correlate. Some time zones, missing packets, servers, stuff like that. When you have such a big amount of data, this happens. The other problem is around the business models, the commercial models. So as I mentioned, there are very complicated commercial models that have been built in the last 20 years. So let's say that you work now between Verizon and Deutsche Telekom now, and they have an agreement that says that if they pass a certain threshold, they get a discount. But they have a commitment for specific areas in the world. And they have another agreement that is based on the data-only things for IoT. Because these agreements are not saved in a centralized server, like you would imagine that there will be some kind of a SaaS that everybody connects to, and they put all the contracts there, and then it makes the calculation, and it tells how much money each party needs to pay to the other, or actually making the payment, right? Reality is that these companies don't want to have a centralized party have all the sensitive commercial data of them, because then they will know about all the businesses happening in the world. And this is kind of an international business of very big companies. So each company makes this calculation by themselves, and then they share the result. But because there is no formalized way to do that, each one gets a different result. And then they start disputing on this and finding, what is right and what is wrong. So this is the problem that happens in the roaming. I can tell you about other problems in other products. I
felt like you're about to answer the question I was thinking about, which is how you're going to solve it. Before you talk about that, how did you get exposed to this? This is not something the average person would have visibility into.
Yeah, that's true. It was by mere coincidence, I would say. I was exposed to another settlement problem in the telecom space, which I thought I could solve with smart contracts. It was early days of Ethereum, ICOs, 2017. And I thought that, hey, this is a problem that can actually be resolved by this, which is not just a way to raise money for raising money. This could solve a big enterprise's problem. So I was intrigued by this thing. And when I started drilling down, I understood it happens in different types of products within the telecom space. But not only there, I realized that it happens also in other verticals, like in the energy space and, anywhere where you have big companies that trade multi-record complex products. So this is kind of the reason why I thought that this is interesting. So it was a mere coincidence for me to discover this. I can tell you that I knew about this problem from a previous company that I had and I sold, which was advertising technology company. It was doing algorithmic trading of video ads and having a direct publishers business. And because we've automated all the aspects of buying and selling media, but the department that we had that had to settle in the end of the month got more and more people. And the reason why that part was manual, because no one had a solution to automate, and we had the same problem, discrepancies in ad servers. They had that amount of impression, that they had that amount of impression, and you can't settle the bill. I had CEOs of other companies coming to me and telling me, hey, we found some fraud. Google didn't pay to us, so let's split all these kind of things. And I said, it doesn't make sense, and this thing should be automated. So this is when I first came with this idea of trying to automate this using smart contracts. And then I was exposed to this. It happens also in the telecom industry, and it was kind of an opportunity that we started working on, and this is how we ended up doing all these solutions.
That's super cool. So it sounds like the entrepreneurial filter that you applied to this layer of industry was there's large companies that are trying to settle who owes who what for what, and there's a bunch of rules in place. So the rules for monetary exchange are complicated. The players are very large, and they each have a lot of things, in this case, like consumers using their products. So it's very large people trying to figure out which complicated contract applies for this specific case. And then that would be a perfect condition for sort of, do you look at the application that you're building as a sort of neutral ground that each of the teleco providers can enter voluntarily their information, and then it can be accessible to everyone. I'm curious what the solution practically looks like.
Okay. So if I continue the example we had before, that we could have one centralized SaaS that would do that, but because of the reasons of privacy and competition that I mentioned, what we built is a infrastructure, is a platform that allows you to do the same thing, but in a decentralized manner. So each of these enterprises have their own node, own copy of our software. So we don't run any nodes there. It's just our customers, and we help them integrate their operational system that have all this data, coming from all the users' transactions or contracts that they have into this node. We also allow them to define contracts with the user interface that we build that allow them to design the contracts and agree and sign them cryptographically between each other. And then the data is being processed by these contracts. And because it's the same logic running on smart contracts, they get the same results on both ends. And then they can settle automatically. So no more disputes. They can shorten the settlement cycle. They make the payments smaller, so they can eventually move into like on-chain payments or faster payments using that. And then they can go and do much more complex transactions. They can go to do a lot of on-demand stuff that they can't do today. So that kind of open up the type of products, the complexity of them, that allows them to handle more SLA type of things. So to say like, I'm selling this to you and I'm committing that this will behave in this way with this latency, with this bandwidth. And if not, you'll get compensated with this amount. And today, this is all handled manually. So it's very limited what you can do with this. But now they have these systems, they can get much more complicated. And this is very important. I can explain why in a second.
Yeah, I'm really interested on how you set this up. So there's a server that each of the customers run. Presumably there's only a few large telcos, right? You're talking about dozens. I mean, we're not talking about hundreds, are we, across the world?
Dozens. Yeah, at the moment it's dozens. Yeah,
and they would each have one server. So would this be something like their IT team spins up a server dedicated to running this node, separate from everything else, and then your team, probably manually and through software, help pull through API, pull in the data from their database into this node? Yeah.
They don't have to run it on their, like a lot of the big ones are doing it on their IT system, but we also have like a hosted AWS version with a one-click install. So they can get like an AWS one-click install. We install everything, the blockchain nodes, our software, everything, and then they just plug into the API and they can do it. So it could be quite simple, and it would be quite complicated depending on the IT requirements.
Where do they usually, you pitch this to them? What's the first few questions they usually ask? Are they concerned about privacy of their data, or what else are they generally concerned about?
I mean, I won't say which customer, but like some of the customer have one of the customers that we have 700 questionnaire for the and privacy. So I think number 49 was a good question. So they don't ask the question; they send it. They mail you they email you the form. So yeah, they ask tons of questions. I think the main thing that they are concerned with, in the beginning, is the business value that they get. Like, they try to understand how much this automation will help them. Others are, trying to see if this is going to make too much automation, and there's all kind of things. Generally they are very fascinated about the technology. They try to understand, is it truly private? Does, others really can't see that? Can you really not see the data? All these kind of things that are very different from a normal software, right? So these are the kind of things that they are intrigued about. And then, they're interested in like, how would they take their format, which is different, and make it compatible with the format? What are the tools that they have to do it? So these are the kind of things.
Yeah. So they want to make sure, obviously, that their data is private. So hence the idea of hosting it on their own server. And then through the blockchain protocol, only the data that's necessary to share with their like friendly competitors are going to be shared. Once they understand that, they want to know, how does this help them? Which I'd imagine the primary pitch you give is, hey, the average telco company spends, I don't know, $20 million or some large amount of money going back and forth in time. So you have a huge department of internal customer service, whatever that's called. And that's a big line item on their balance sheet. Is that generally the pitch, like reduce cost of their?
So yeah, efficiencies is the pitch for this product line. But it's not only reducing FTEs, like reducing people that are doing that. It's also it's shortening the cycle of payments, which is good for net receiver, not necessarily good for net payers. So depending on on the audience, this pitch is relevant. Another very interesting thing that we learned is, because there's so many disputes, and people they get emotional about this. You don't pay me. I don't want to do business with you. Why you don't pay me? This is the numbers. What they start seeing is that they are losing business with this partner when it's in disputes, because they don't do new deals. It's very hard to negotiate, because the teams are kind of, if there's now $1 million in line, so hey, pay me the $1 million before I'll do another business with you. And he's saying, but the data is not right. And so by reducing this amount of disputes dramatically and shortening this cycle, there is actually more business coming between the companies, and this is a big thing. Another thing that we see is, because this manual systems, you have a lot of kind of unused stuff. So going from the roaming to another use case that is interesting, around the fiber connections. So the conversation we are doing now is running on a lot of different fibers connecting between us. Now we are running on the free internet, but if we were in a big enterprise, we were probably running on our own MPLS connection, getting more crystal and fixed quality image between us. And these type of things cost money. And whenever you have an organization, like let's say you will go to Verizon to get this line, and I'm in Tel Aviv, Verizon doesn't have any access to here. So they would have to buy maybe from BT or from Deutsche Telekom, and then from a local provider here in Israel, Bezek, to allow this line that will connect between us. So there's another huge market of fiber connectivity, different type of things, layer 2, layer 3, Ethernet, IP, that needs to be settled, because then they need to pay to all the others that are using. And then let's say that we close the branch in Israel, they need to cancel this. But because everything is quite manual, they sometimes forget to cancel it. Mm-hmm. So there's a lot of unused lines, about 5 to 7% is the statistic we got from our customers, of an inventory today that is actually unused and getting paid for. So a lot of the things we're doing by getting into the system is kind of just getting organized, all of that stuff, and you save a lot of your costs. So there's a lot of different line items around that, because if you work in this massive scale and you don't do it in an automated fashion, you have a lot of inefficiencies that we address.
So 5 to 7% of the cables that are around the world laid for internet are not being used, or being paid for and not being used?
Let me make this a little bit more accurate. On the international connections, okay, between the paid internet cables. So what we're doing now is a non-paid, right? It's what's called free peering. But if we were in an enterprise and we were connected, then 5 to 7% of these lines are being paid for but not used.
Wow. So is there I mean, I'm not aware of this, but is there a separate, are there multiple layers of internet where you and I are using what you call the freed version? And then there's this, what is it? MPS, NPMS? That's
MPLS, yeah.
MPLS. And what is this? What?
Okay. Do you have fiber to your home?
I do.
Okay. So, but so your fiber, if it goes and connect to another fiber, another fiber with different routers, and the way it gets to me, right? Now, there is different priorities of the packets that are running there. And if there is now a lot of bandwidth that needs to go, so some of the packets will wait. And then you will see me getting pixelated a bit, right?
Right.
Because you didn't get all my pixels at the same time. If we would have a dedicated cable, connected you and me throughout the world, like different cable segment that we bought, and it's only us using it, we won't see this pixelizing thing. Right?
God, how do I get one of those? How much is that?
I'll hook you with someone. It's quite expensive, right? So it's something like this could cost $10,000 a month, or depending on where in the world, it could be more. And this is why consumers are not using it, because it doesn't make sense on the consumer scale. But if we are now two branches of a big organization, it makes sense to do this type of thing, and all of us are using it, and sharing and getting much better video conference quality, for example. One of the things that,
I was going to ask, so this would generally be reserved for Fortune 500 companies? Is that about the scale of the companies that pay for this kind of?
So today there is a concept called SD-WAN, software defined WAN, which is that can run on both MPLS and standard Ethernet. And the SD-WAN is doing better prioritization of the different protocols. So if we will say what we are doing now, this conference is the most important thing between us, it will prioritize the packets and get us a better quality than this is this is rather cheap, much cheaper compared to the MPLS. One of the things that we are working on, without getting into too much details that I can't get into, is to enable these type of interactions, even with the MPLS and stuff like that, for end users. I can tell you that one of our customers, a company called PCCW Global, they have a product called Console Connect, and they kind of allow you to get some bandwidth on demand between different points, where you can pay like in a SaaS product. So this is kind of a beginning of this thing. But when this framework will be widely used, a service like Riverside could have a button saying, I want to buy better quality for this podcast. I'm willing to pay $100 maybe for a session and get the super quality, like this end-to-end fiber just for us for that period of time. And this is the type of use cases that are going to be possible using this type of technology.
That's so interesting. That's so practical, because it feels like, from a consumer's perspective, there are some times when it's worth a lot more that you have high integrity, fast, low latency connection like this, right? Once we stop doing this podcast and I open up Slack and Evernote, then my bid would drop down what I'm willing to pay. I'm willing to accept slower times. It's like driving on the highway. If there was an intelligent traffic network and you say, okay, I'm late for this meeting, I'll pay. This person is going to their book club. But we have no way to communicate that. It seems inevitable in every large network, but Yeah. When do you think that'll be, not necessarily whether, I'm not looking for a timeline on you releasing your products, but when do you think the average person will be able to go on the internet, open up a browser, and set a bid price for higher internet? Is that 5 years away, 3 years? Does something has to happen for that to be released in a big way?
Yeah. Okay. I'll explain a little bit more, and then we can get. There's several things that needs to happen. First of all, you need automated provisioning of the network elements themselves. So today, most of the companies, they need a technician, an engineer, to configure the cable to work in a certain way and to connect it between the different parties, right? There's something called NNI, it's a network-to-network interface, and it needs to be configured between the two networks. So depending how many networks are between us, there's multiple configuration that needs to happen. So some of the companies, like Console Connect that I mentioned before, and Colt, that is another customer of ours, already have this level of automation in many of the network. So they can support it. Others are still working on it. And that means that until they will reach a critical mass of coverage for this in the world, it won't be possible. Okay, so that's one thing that needs to happen. Then the second thing that needs to happen, and this is what we are building, is the commercial framework for this, right? So you need that to make sure that once you chose to use this for 40 minutes now, and you used 5 different cables in the world, that your money is going to be split between them in the right way, right? This is the type of settlement framework that we have to do that. So you need both the network side and the commercial side to work together to enable this. And this, as I say, it's already available in some territories, and it will become more and more available. I would say in 3 years, we will have decent availability of this in the world, and probably start seeing more and more integrations around this. 5 years, we should have this as a common thing that we all know.
Yeah. I wonder about this, whether there's more of a market for countries who are less developed, has less developed infrastructure, say like in Africa, parts of Asia, versus the US or parts of Europe that have just had internet infrastructure around longer. Countries like the US have invested more into the internet infrastructure, but of course there's this concept of leapfrogging where they've invested so much, so it's difficult to spin that up. We have telephone wires all over the country. Africa uses just cell phones because they never invested in that. Do you see this kind of thing launching or taking off more so in less developed countries, or is there more of a financial incentive to have it for more developed countries because the companies are there?
So you're absolutely right about the leapfrogging. In Africa, we see companies that build a network from scratch with this ability because they started much later and they don't have the legacy. So in terms of technology, it's easier there. In terms of the kind of financial capability to pay for the connections abroad, it varies, right? So I don't have any data about this in Africa, but I think Africa is more ready than many of the Western countries in terms of the network technology. Yeah,
that makes sense. So you were going on a thread there, and I feel like I sidetracked you a little bit. So you're working with these companies. I find it fascinating to learn how the internet works on a more granular level, and then what's the evolution of the user experience and what's underneath the hood, like how the wiring works. And most people have no idea.
Yeah, it just works, right?
Yeah.
But I think that we are seeing more and more experiences that we are getting exposed to, that the standard internet doesn't work as well. It's when you get into this metaverse ideas, If we were now sitting on a rock by a lake in a virtual reality world, and we had this conversation, and we can walk around and stuff like that, that's going to be cool, right? But think about how pixelating us would feel, even worse, and it's going to be even worse. So we are just approaching into a world where this low latency, high bandwidth use cases are going to be like a day-to-day thing, and this is going to be very, very interesting to help solve that.
Do you feel like there's a physics problem with the existing infrastructure in terms of the amount of data? Say for this example, say you and I wanted to throw on VR headsets and be next to each other with the fidelity or the data as we just see it. Like there's just no difference between what I can see right now out of my eyes and what I would see through VR. So there's some finite amount of data that I would need from you to recreate your image visually in my VR. Is that data possible to get through the existing pipes, or do you think we just need to completely rebuild or use satellites, or just what's your thought on that?
The current infrastructure cannot support it. It's said that I didn't experience it, but it said that you need about 16K. So the standard Oculus, like the Quest 2, is about 2K. And you need to get a 16K to get the fully immersive, like to see how you see the world. So that's huge amount of bandwidth, and you need to get it in a very, very low latency. So to be able to get something like this, you need a different type of infrastructure that exists today. With 5G standalone that started to now roll out in the US, you get a better better ability to do stuff like that. With the next generation, like with 6G, that's probably going to be like what will get us into this area. And there's a lot of other things, because you get a lot of load on the fibers in the middle. There is satellite connectivity that is now getting into play. I don't know if you watch like the development of Starlink, what comes from SpaceX. But the new edition of that should provide a 20 millisecond latency, to the satellite and back to different areas in the world with kind of 100 megabits. So the technologies are getting there, and there's a lot of money being deployed on this type of connectivity protocols. But there's going to be another problem of kind of matching it all together into a global network, and handling the commercial aspects around that. So these are some of the things that we are looking at. Yeah,
fascinating. I want to ask you about the structure of the company. So when you start a company in an atypical way like this, you're pitching not a subscription service, right? It's not as if, and tell me if I'm wrong here, but I assume that there's a layer of currency that you're creating in the network so that Verizon and Deutsche and everyone will be able to facilitate these payments between each other very quickly using smart contracts. Is your business model to own a percentage, some percentage of the currency, some percentage of the tokens flowing through the network, add value to that protocol, and then see the value of the token rise and then make your money that way? Or is there subscription, or how do you think about structuring revenue models?
So in the beginning, that was my thought. We also generated a very interesting stablecoin called ESDR. We were tokenizing SDR, which is special drawing rights. It's the IMF currency. It's a weighted average of the 5 biggest currencies in the world. And the reason why we've done that is because that's the standard settlement in telco between them, like in roaming and in other areas. And it's coming, back from the days, with very high volatility between different currencies and having telco like linked to the country and stuff like that. So that's the currency that everybody used. And that was backed by money market funds from Fidelity, which are our lead investor. And we created a very interesting structure. Everything is using zero knowledge proof, so you don't see and you don't know which pays to who pays to whom. And that was quite a groundbreaking technology back then in 2018. The problem is that we found that telcos are a bit slower in the adoption of any financial software. And they are okay with using the blockchain-based smart contracts to agree of how much they need to pay to each other, but they still want to pay in the way that they pay normally. So we had to work in a standard subscription model to start with. And without getting into much details of what we are working on right now, because that will be a subject for another conversation, but we are working on a kind of a Web3 protocol that is public and is more along the lines of what you are just mentioned. But we needed to do the whole journey to be able to win again the ability to do something like this.
Yeah. Most protocols will take that route if they're consumer, because it makes sense. They're focused. Oftentimes I talk to people who are building protocols whose goal it is, after they raise money, to dissolve the company itself. So they don't even want to have a company. They build a protocol, they drive up the value of the token, and then they sell tokens at a higher amount. You guys, quite a bit different. I imagine you structure it as a typical company, and then on the outside in the beginning, it looks very similar to its normal product that you're selling. But then, of course, you head in a different direction with Web3. I imagine just the nature of large companies, they're slow in adopting new payments, like they have their whole financial system. I could see that. That makes a lot of sense.
Yeah, we're getting there. This is a journey, and what's nice about these companies, and why once they adopt it, and the volumes are big, and they do it. So yeah, it's a long journey just to pass the privacy, security, all that type of things with these companies, and have this service running, on their premises and connected to their financial systems. It's a several years journey to reach there, and now we're there. Like this latest software I just told you about, around Fiber, is just about to go live with multiple companies. That's the one that I told you that's been marketed by our customers in the Dubai convention. And this is a big thing. Like, companies are going to now invoice each other based on this, and this network is expanding. So we expect that these type of networks that we are creating are going to eventually become, this one large network with on-chain payments and more DeFi abilities.
Do you know what goes into an upgrade to 5G? Is that I'm not sure if this is something you've dove into deeply, but it wouldn't surprise me if you do. The extent to which 5G varies from 4G or 6G to 5G, are they laying new wire or putting up new satellites? Is it the technology that they're using to pass information back and forth, like the software more efficient or different frequency bandwidth? Like, I hear a lot of people talk about 5G, the improvements. It's obviously faster is the reason that you upgrade. Yeah. What are your thoughts there?
Yeah, sure. So every generation is a set of frequencies, first of all. So the higher the frequency, it goes faster. It means that you can have more data at the same period of time. So that's kind of physics. And 5G is higher frequencies, and then what it means is that you need to have to install physical bases that will be able to work in these frequencies, and you need to have in your phones different types of modem that knows how to get these frequencies and translate them into data. So that's a work of both the kind kind of Qualcomm and other companies to make these chips. And then there are companies, like Ericsson, Nokia, and Huawei and others that are making these base stations. And then the cellular companies, they need to put these space stations everywhere to get coverage. So that's a lot of money that needs to be spent in order to do that. Now, as the generations go up, you need to have, because the frequency is higher, you need to be closer to the base station for this to work. So you need to actually have more base stations to make this work. So it's even more expensive to do. Now, in 5G, there's different types of frequencies. And the higher they go, or the different standards, and the better the standard, the better the performance, the lower the latency, the higher the bandwidth, the closer you need them, more expensive to generate. So in the US, for example, there are like mid-range 5G now that was finally deployed several weeks ago. There was a lot of issues with the airplanes. So airports had some issue with this frequency, and they couldn't improve it. So for a long period of time, Verizon and AT&T, they couldn't get approval for these frequencies, but it was finally resolved. And there are other better frequencies. So this is one thing that you need to do, these base stations and all this stuff. The other thing is the core of the network. So in terms of like today 5G, most of the 5G that you know is still using the previous core. It's using the core of the 4G. So it's just like you get a faster thing, just from you, but then you get to the same core. The new core of the 5G is what's called 5G Standalone. And that enables you a lot of other capabilities that were not there in 4G. One of the biggest new things is what's called network slices. And network slices, and we spoke about it a little bit on the pixelation thing on the fiber, it's saying even on the wireless side, you can have priorities. You can have like a network slice that is the guaranteed lowest latency. So only you there, or a few others, and you know that every packet that you send will get immediately to the core. And that can give you a much better experience and much lower latency. So if you do a VR session, or you play a multiplayer game, or you have like a drone doing surveillance and making decisions based on the video that it's getting, you would want to get a lower latency, and you will be happy to pay for this. So again, there's all these commercial aspects, and this is what we are enabling, all these commercial aspects of how much you need to pay, how do you do it, how do you settle it with all the different parties around that. This 5G standalone is something that is slowly rolling out. Most of the 5G in the world is still not standalone. And when we get to the standalone, you'll get these network slices, and you get another component, which is an edge compute. Edge compute is a computer that sits near the space station, very close to you, and can serve you in different ways. And when I say serve you in different ways, if we go back to the VR example, if you want to have a cool glasses, and you want them to be a VR glasses, they don't have the processing power, you can have the edge compute process the image in the world for you and just send it to your glasses. And you need to have this ultra low latency that it will send you the image, and you will feel like it's happening in your glasses. This is the type of experiences that will be enabled with the full 5G standalone experience and with edge compute.
That's edge compute in particular seems like the big breakthrough. It sounds like a completely different way to architect the infrastructure. Yeah.
Yep. That's going to be a lot of things are going to move to the edge. In general from the cloud.
It seems like that has been, it seems like we go back and forth, right? Servers used to be in every restaurant, in every house, and then they go to the cloud, and then we have our devices in our hand, which are in a sense edge compute. and then the network kind of expands back out. So then it's in every telephone pole and every major base station. It's fascinating to think about that.
There is always this movement of centralization, decentralization, centralization, decentralization. We had mainframes,
dude,
right? And then we had thick clients, we had computers. And then we go back to like thin clients with web. And then we have the mobile phones. And it's always doing this.
It's like,
then we got the cloud, and now we're getting edge computing.
It's like the AI is just breathing. It's like it's just alive. It's like we're the bootloaders for the AI, and there it is. I want to ask you that last question. Do you? This is just something I because we're on this topic. I've heard a lot of people talk about the health concerns with 5G, and I went to the dentist this morning. I got X-rays. They step out of the room to give me X-rays because the frequency of the X-ray is so high, and gamma rays and all these rays are very high up on the spectrum. They contain a lot of energy, and that radiation can do damage to our cells. There is, I'm sure, a lot of research that is done by the telco companies themselves, but similar to pharmaceuticals, there's a concern by the public that the people funding the research, the organizations funding the research, are the ones who are the most biased. And now that doesn't necessarily implicate those companies in doing anything wrong at all. In fact, I think the vast majority, it just has to be true. But then there's also, when you run any kind of study on human beings, there's gray area and there's ways to tilt that bias. I guess the question I'd want to ask you is, how confident do you feel in the integrity and the thoroughness of the research by the telcos on the health implications? Are you 0% concerned, or are you moderately concerned, or where do you fall in this? Because presumably there's some spectrum where it will be, if they're blasting X-rays on every street corner, right?
Look, first of all, I say that I know nothing about this.
Okay, and, fair enough.
You asked me a lot of other questions I could answer. I could tell you that cigarettes will kill you, and they were researched by the tobacco companies to be not dangerous for many years. So I would say, like, I don't know what to say about this. I remember when I got my first cell phone, it was like a small Ericsson phone. And my mother was concerned that this is like very dangerous to my brain, so she talk only far from me and stuff like that. And we all use them, and we grew up, and it seems like we're kind of fine. So I don't have an answer. I think nobody really knows. I will know with time, and I would say that if it is dangerous, we would have a very limited population in the decades. So,
oh God!
That's
Well, the scary part is if they invest all this money into this infrastructure, it would be very inconvenient for it to be revealed that it has some negative health implications. But so were cigarettes, right?
I remember the COVID stuff. There used to there was a conspiracy that 5G created or unleashed COVID or something like this. So there's so many types of things that are happening. Yeah. So I don't know, and I don't think it's like cigarettes, but I'm not a professional on this, and it might be dangerous, and use it on your own risk.
Yeah. But maybe use speakerphone instead of putting it to your ear. I don't know. Well, at least we kind of all go down together on this one. If they just blasted their ways. Hey, I know it's late your time. Eran, thanks so much for hopping on today. Where are you publicly visible online? Do you write or tweet, or is there anywhere people can follow you individually? And then I know the company's URL, ClearX.io. We can talk about the company too, but where can people find you?
So I think I'm a bit active on LinkedIn. So under my name, and also the company is active there. I'm also kind of active on Twitter. So maybe just saying this now will make me more active and to put some more interesting stuff. So feel free to open. It's the same name, and you can find me on Twitter. And yeah, like come to the website, follow us on LinkedIn. We're going to release some very, very interesting stuff around Web3, solving a lot of the problems that we just mentioned during this. So it's going to be very interesting times, the next few months. Yeah.
Yeah, awesome. And we didn't talk about it, but you're on the advisory board of JFrog and Venn, which look like two very large, successful companies, which I'm sure keeps you busy. You're based in Israel. If you're ever in Portland, where I live, hit me up, man. Would love to meet up. Do you have any people that you follow or that you've learned a lot, or books that you wanted to throw out if people are interested in this topic and wanted to learn more?
First regarding Portland, I think that I once heard that you have under the city the biggest, largest mycelium in the world.
Yeah, it just creeps up. It just. I didn't. I know there's a. I just moved here, so I'm learning this. Maybe I'm being affected by the mycelium, but there is a huge park here. It's the biggest park in the U.S. In any city, Forest Park. It like covers half the city. So it's pretty amazing.
Cool. Regarding things to learn and stuff like, I follow different type of people and consuming different type of content. I would say that I recently listened a little bit more to Benjamin Hartley. He's a guy that is kind of a motivational psychologist, and is a very interesting guy. There is an item that he's keep repeating on that I like. That the thing that blocks you from getting to your kind of big goals are your lesser goals, and this is something that kind of inspired me lately. So I would recommend people to go and listen to him. What else I can recommend? Probably everybody knows Naval Ravikant, so I follow a lot of his stuff, and the book that he released, I think, is great. So also recommend that.
Cool.
The other things will be on Twitter.
Cool. Well, I'll check it out. Eran, so nice to meet you, and congrats on all your progress, man. Keep crushing it.
Thank you very much. It's been a real pleasure.
Take care.
All right.